Okay, so remember what this whole lesson started with. We're trying to form an interval for the population mean. We have already talked about how to get a good point estimate. We use the sample mean. We just learned the formula to get the margin of error, which tells us how far to the right and how far to the left we can move. So now we're going to talk about how do we actually construct this confidence interval. Well, if we know how far right and how far left we can move, let's think about where we ended up. Well, if I started at x bar and I moved e to the left, then I ended at e minus x bar. That's where the interval will begin. I said e minus x bar, but I meant x bar minus e. That's where the interval is beginning. And then the interval is going to be ending at x bar plus e, because we started at x bar and we added the margin of error to the right. And we do know that the formula for e is that e was equal to z sub c times sigma divided by the square root of n. And please don't be confused by the different ways that we can write this. It's the same thing as just writing the z sub c in the front and then putting that by keeping the sigma and the square root of n together in the fraction. It doesn't matter. Those are written the exact same thing. They'll say the exact same thing. Okay. And then again, the whole interpretation of this interval is that the probability that this interval contains the parameter that we're estimating, the population mean of mu, is C, is whatever level of confidence that we chose, assuming the estimation process happens over and over and over again. So the more it happens, probably the more likely it will be. So let's talk about the steps. Sometimes I find that students find it helpful to have like a list of steps that they are following when they're doing a process like constructing a confidence interval. So let's outline very clearly what we're going to be doing in these problems. The first thing we're going to be doing in a problem from this lesson is we will be verifying that the population standard deviation, sigma, is known, given to us in the problem. Because if it was not, we would have to use a different formula to find the margin of error. I talked about that briefly in the introduction video. We also need to know that the sample is random and that either the population is normally distributed or that the sample size is greater than 30. These are things that we have mentioned earlier in this presentation. These are requirements from the central limit theorem. Once we have verified all of those things that basically just tell us that the formula is valid for us to use, we need to go find sample statistics. We need x bar, which is the sample mean. And we do know that we find the sample mean by adding up all of the x's and dividing by whatever the sample size was. This is your point estimate. This is the thing that's in the middle. The sample mean is your point estimate when you're trying to estimate the population mean. That's the thing that is in the middle of your confidence interval. And it may be easier for you to do that using technology, right? So we can very quickly like use StatCrunch, paste some data into StatCrunch and find the sample mean that way, or enter some data into the table on your calculator and find it that way. You do not have to like always add them up by hand. Then once we know what our sample mean is, we need to go find our critical value, Z sub C. And that depends on the level of confidence, right? So we need to go in and then find what are these values. Really, you're only going to be using the positive one in the formula, okay? You use the positive one in the formula. Do not use the negative one in the formula. There are always two for a confidence interval, but we plug the positive one into the formula. And this can be done using StatCrunch, a calculator, or the standard normal table. I think you will probably find it will be easiest to use the standard normal table because the standard normal table just gives them to you. We will only be looking, or let me not say only, but very rarely will we look at a confidence interval that is not 90, 95, or 99%. Okay, so for the most part, the ones that we need will be right there on the table for us. Once we have found our critical value, we then have all the pieces to go in and apply the formula for the margin of error that E is equal to Z sub C sigma divided by the square root of n. Because sigma was given to us originally, we had to find n and x bar. So I do know what n is. And then in step 3, we went and we found the critical value. So we had all of those pieces. Once we have the margin of error, we are ready to start forming the confidence interval. In the middle is your point estimate of the sample mean x bar. Off to the left is your left endpoint, because you moved you moved the margin of error away from the sample mean. To the right is your right endpoint, x bar plus e, because you moved to the right e units from your point estimate in the middle of x bar. So the entire confidence interval is the range of numbers between x bar minus e and x bar plus e. So now that we have outlined the steps to construct a confidence interval and we have defined what one is, we will now look at several examples where we construct confidence intervals, we make them, and then we also interpret them. We give a brief one-sentence explanation of what this confidence interval means in the context of our problem.